Assalamualaikum and a very good day everyone. So today we are going to learn about chapter 7, which is animation. So what is animation? So by definition, animation means that the act of making something come alive. It's not just that, it is making static presentation comes alive. So we have PowerPoint as our static presentation. We could also add an animated value to it so that it becomes more interesting. And animation is also an object that actually moving across into and out of the screen. It depends on the size of the project, in which you can animate the whole thing, the whole project, but not just that, you can also animate some part of it. And visual effects such as wipes, fades in, fades out, zoom in, zoom out are available in most multimedia authoring packages. It's not only that, but it can also be found in PowerPoint, as simple as a PowerPoint. So let me just show you an example. So we could have, if you go to your PowerPoint, you can go to the menu animation and you can animate things. For example, let me just show you. So you can basically animate this part. Choose any of the animated design that you want, like fly in, float in, split, wipe. So we could have so many examples of animation, like coloring the line, lighten, which you couldn't see from here because I'm using a template. Okay, so as I mentioned, animation is not just fades in and fades out, but it is actually an object that moving across, into or out of the screen. So animation has become a primary source of not only static presentation but more into dynamic action. Okay, so now let's try to look into some of the principles in animation. First principle is related to our biological and psychological phenomenon, what we call as five phenomenon. So in five phenomenon, an object that we see remains chemically mapped on our retina for a brief time after viewing. And with our human mind that needs to conceptually complete a perceived action, this will allow an image like this to be distinguished as a perceived movement in stationary objects. So these are basically stationary objects, but because the illusion as visualized in nature, this causes us to distinguish it as a perceived movement. Okay, so let's look at the second principle. With second principle, an animation can be built by a series of images. For example, let's try to look at this picture and this and this. This picture were actually a series of images. For example, like here we have a series of images which, if we draw these images single image on a single frame and we change the frame very slightly and very rapidly one after another, we could see that these images are actually blend together into a visual illusion of movement. For example, like this one, we could have 9 frames of images per second, or we could have 6 frames of images per second. And finally, the third principle, which talks about typical shutter rate for movies and film, which is about 24 frames per second, in which, in general, if the animation being played at about 1/15 frames of a second, this will actually create a jerky and slow movement to the animation. This is another example of persistence of visions, which you could probably found in a place like Petroscience. An appropriate software and techniques will allow you to animate visual images in many ways. The simplest animation can occur in 2D dimensional, for example, the Frozen movie, and also as complicated and more realistic animations which can occur in 3-dimensional, for example, like the Toy Story 4. When you want to create an animation, it is advisable for you to organize its execution into a series of logical steps. For example, in the picture, you are trying to animate a person which is trying to jump back and forth. So, what you should do is that first you need to gather up in your mind all the activities that you wish to provide in the animation. If it's too complicated, then you may wish to create a written script with a list of activities and required objects, and then create a storyboard to visualize the animation. Next is for you to choose the animation tool best suited for the job, and then build and tweak your sequences. So the cell animation started off with a famous Disney, in which they use a series of progressively different graphics or cells on each frame of movie film. A 1-minute animation of movie can require as many as 1,000 separate frames, and each frame may be composed of many layers of cells. So, what is cell animation? Let's look at this example. So, in cell animation, the artwork begins with what we call as keyframes. So, the keyframes is actually the first and the last frames of the action. For example, if you are trying to draw this animation, you would have to plan where it should be your first keyframe of the object and the last keyframe of the object. The series of frames in between the keyframes, which are the other circles here, are drawn in a process of what we call as tweening. So tweening is an action that requires calculating the number of frames between the keyframes and the path the action takes. In computer animated programs, is typically a program that employs the same logic and procedural concepts as the cell animation. It also uses the same vocabulary like the classic cell animation, such as layer, keyframes, and tweening. The only primary difference between different animation software programs is that some programs require the animator to draw an amount of object, and how much it is automatically generated by the software. Let's look at an example. Let's go back to this example here. And another example here. So, in a 2D animation software, for example, an animator will need to create an object, in this case, the birds. So they will create this object which will be imported, or they can just use any clip art object and describes a path for the object to follow. In this case, it's the flying path. The computer software then takes over and actually creating the animation on the fly as the program is being viewed by the user. So kinematic is the study of the movement and motion of structures that have joints, such as walking man. So animating a walking step is tricky because you need to calculate the position, rotation, velocity, and acceleration of all the joints and articulated parts which are involved, such as knees, bend, hips, and flex. This is one example of software called Smith Microsposer, which allows user, and it provides the user with pre-assembled adjustable human models such as male, female, infant, teenage, which can have many poses such as walking and also thinking. Next is inverse kinematics. So inverse kinematics is also a process by which you link the objects such as hands to arms and define their relationships and limits. For example, your elbow cannot bend backward. So these are the relationships that needs to be defined in software such as Maya 3D software. Once those relationships and parameters have been set, then you can then drag these parts around and let the computer calculate the results. Let's look at the slide on page 8. This is another examples of morphing. So morphing is a popular effect in which one image transforms into another. And in morphing applications and other modeling tools that offer this effect, we can then transition not only between still images but often between moving images as well. The last slide talks about the different formats for animation file format. So the most common ones are probably Director, Flash, the ones that we usually heard of. And between all of these animation file formats, if we want to play our animation on the web or in other operating systems, it may involve a compression, such as compressing the Director native movie file, which has the .dir extension, into Shockwave animation file. And the other example is converting between the Flash native file into the Shockwave Flash. It also involves a standard digital video file container to play on media player embedded in operating system. So different operating system requires different standard digital video file container. For example, like AVI, Movie, and also MPEG, which are commonly used in Windows operating system. For more reference, you can go to this website which has additional information about basic animations, where it talks about different types of animations as well as different types of useful software to create animations. Now let's go back to the slide, where next we are going to do some hands-on activity, but not in this video but in the next video. So I'll see you there.